In this lecture, we are going to see the concept of logarithms in mathematics. All right, let's get going. So now here's a number 3 raised to the power 4. What it can be written as 3 into 3 into 3 into 3, right? And the value is 81. So 3 to the power 4 equals 81. This is called as the exponential form. Okay. So now how can we write this exponential form as a logarithm? I mean, how can we write the logarithmic form of this thing? Okay. So that's what we are going to see. So here it is, log 81 to the base 3 is equal to 4. This is how we can write an exponential form as logarithmic form. Okay. And 81 is called as the argument, 3 is called as the base, 4 is called as the answer or exponent. All right. So writing it in a general format, logarithmic form will be log of a to the base b is equal to x, and exponential form will be b raised to the power x is equal to a. Okay, so that is how we can write the exponential form. All right, so now I'll give you some examples. Log of 125 to the base 5 equals x. Okay, so now how can we write this in as an exponential form? In exponential form, I mean, so it can be written as 5 raised to the power x is equal to 125, right? So that's this is the exponential form of this. And like, what is the value of x? You need to find the value of x, right? 5 into 5 into 5 equals 125. So 5 cube equals 125, otherwise 5 to raise to the power 3 is equal to 125. And comparing this one and this one, we find that the value of x is 3, right? So x is equal to 3. Okay, so here's another example for you. Log 1 to the base 4 equals y. Okay, so we need to find the value of y now. How can this be written in exponential form? 4 raised to the power y is equal to 1. 4 raised to the power y is equal to 1. So we know that any number raised to the raised to the power of 0 is equal to 1. Okay, so here value of y is 0 because 4 to the power 0 is equal to 1. Okay, so value of y is 0. Now we are going to see the properties, conditions, and rules for writing algorithms. Okay, first the properties. Log of 1 to the base b equals 0. Okay, so this is the property, first property. All right, and here's an example of this property. Log 1 to the base 8 is equal to x, right? So I'm just going to write the exponential form for this. 8 to the power x is equal to 1, which implies 8 to the power 0. We know that any number raised to the power 0 is 1, right? So in order to arrive at this answer, the value of x should be 0. So x is equal to 0. So log of 1 to the base 8 equals 0. So basically the thing is, when the value of argument is 1, we get the answer always as 0. Okay, log 1 to the base b is equal to 0. All right, log b to the base b equals 1. This can also be proven by the usage of an example. All right, so here's the example. Log b to the base b is equal to x, right? So we can write it in exponential form like this: b raised to the power x is equal to b. Okay, and what should be the value of x in order for b to the power x is equal, in order for b to the power x to be equal to b? It should be 1, right? So b raised to the power 1 equals b. So value of x is 1. Okay, so log b to the base b, like if the argument and base are the same, the answer will be 1. Okay, here's another property. Log b to the power n to the base b equals n. Okay, so here this also can be proven by the use of an example. Log b to the power n to the base b equals x. Okay, so this can be written as b to the power x is equal to b to the power n, right, in exponential form. So x is equal to n, obviously. So we can arrive at this equation. Log b to the power n to the base b is equal to n, since x is equal to n. Here's another example with numbers. Okay, log 11 cube to the base 11 is equal to x. How can this be written in exponential form? 11 to the power x is equal to 11 cube. Okay, so the value of x is equal to 3. So we have seen the three properties in logarithms. Okay, the next one is conditions. So this is the general format: log a to the base b, where a is the argument, b is the base. Okay, so the first condition is a should always be greater than 0. A should always be strictly greater than 0. That is this value of a. Okay, Log of 0 to the base b is undefined, and log negative to the base b is also undefined. Okay. For example, if you log of 0 to the base b is equal to x, if you take that, b to the power x is equal to 0, it will come, right? So we can't find a value for x in that case, so hence it's undefined. And the same goes with when the value of the argument is negative. Okay. So but log 1 to the base b is equal to 0 is right. Okay, because b to the power 0 is equal to 1. We know that because yes, b to the power 0 is always equal to 1, right? Because any number raised to the power 0 is equal to 1. So this one's correct. And also this one is also correct. Log half to the base 2 is equal to minus 1. This is also correct. Okay, because 2 raised to the power minus 1 is equal will give you 1 by 2. So the next condition rather is b should always be greater than 0 and b should not be equal to 1. Okay. So the log a to the base negative is not undefined, and log a to the base 1 is equal to x. 1 to the power x is equal to a. We can't find like the value of x here. Okay. So it's undefined. This one's undefined as well. Okay, next one is rules. Okay. So the first rule is logarithmic additive identity. Log xy to the base b is equal to log x to the base b plus log of y to the base b. This is one identity, all right. And the next one is logarithmic subtractive identity. Log x by y to the base b is equal to log x to the base b minus log y to the base b. Okay. And the third one is called as the power rule. Log a to the power n to the base b is equal to n log a to the base b. Okay, this is called as the power rule. And these are you can use these identities while solving logarithmic thing, while solving something that involves logarithms. Okay. And here are some common mistakes that we as students make when it comes to logarithms. Okay. Log x into log y is not equal to log x plus y, log of x plus y. Okay. This is the correct one, this is incorrect. Okay. And also log x divided by log y is not equal to log of x minus y. These are the common mistakes that we as students tend to make. Okay, here's the final one. uh, Here's an example for you. Log 24 to the base 2 is equal to what? That's the question. Without the, you had to find without the calculator, and they have given the value for log 6 to the base 2, which is equal to 2.58496. Okay. So I can write log 24 to the base 2 as log of 4 into 6 to the power to the base 2. Okay. Now why am I writing this as log of 4 into 6 by to the base 2? Because they have given the value for log 6 to the base 2, right? So I have to arrive at one of the things has to be log 6 to the base 2, and hence I write 24 as 4 into 6 here. Okay. Okay, and log 4 into 6 to the base 2 is equal to log of 4 to the base 2 plus log of 6 to the base 2, right? And we 2 to raised to the power what will give you 4. 2 raised to the power 2 gives you 4, right? So the answer is 2 here. Okay. And we know the value for log 6 to the base 2, which has been already given, 2.58496. So we just add these both things, we arrive at the final answer, which is 4.58496. Okay, I hope this video was useful for you in understanding the basics of logarithms. Thank you so much for watching, my dear friends.